what I want to do here is some more power rules. So this is advanced, I guess you'd say it, for this book, I would call it advanced. I have a fraction with a cube root of x to the fourth in the bottom, and I really can't use the power rule in that because I don't have it written in exponential form or to the power of something. So I'm going to rewrite this in exponential form. So that's going to equal 1 over x to some fraction. And notice the 3 is in the bucket. So what's in the bucket goes on the bottom. And the 4 is there, that goes on top. So now I still can't use the power rule because I have a fraction. In order to implement the power rule, I want to bring this upstairs and just rewrite it as x to the negative 4/3. And now I'm going to do the power rule. Y prime is going to equal negative 4/3 x, and now I have to minus 1 from that. So I'm going to write 1 as 3 over 3, and that gives me to the negative 7/3. And again, there's a couple of different ways to rewrite this.
You might have to, or you might want to rewrite this as dy dx equals negative 4 over 3x to the positive 7/3. Then again, you might want to rewrite that as dy dx equals negative 4 over 3. I'm going to put my radical here, x inside. Now the 3 goes in the bucket because it's on the bottom, and the 7 goes here. Some people put the 7 outside. Some people continue to simplify this because that power is greater than that. You can simplify it a little bit further. Dy dx, getting a little tedious. Negative 4 over 3 to the cube root of x to the 6th times x to the first, because 6 plus 1 is 7, you add exponents. And then I'm going to bring that outside. So dy dx equals negative 4 over 3 x. Now the cube root of x to the 6th is x squared. Cube root x. And if you're taking a multiple choice test, you might have to keep simplifying until it matches the choice that you're given. So they say multiple choice. Some people think that multiple choice is easier. It's actually a talent to have to recognize what you're given. And you know how cruel they'll be. They'll make something slightly different in one of these to tempt you.
The power rule derivative, what I'd like to do is rewrite this as a rational exponent. So that's going to equal x over, there's a hidden 2 inside and a hidden 1 there, so that's going to be x to the 1/2. And then I'm going to bring him upstairs. So that's going to give me x to the first times x to the 1/2, negative 1/2. And now I just add exponents, and that's going to give me equals x to the 1/2, because 1 minus 0.5 is 0.5. So now, that's not my answer. That's what I can use to find the derivative. So I have x equals x to the 1/2. And to find the derivative of that, I'm going to use the power rule. So I'm going to do 1/2 times the 1 in front. So the derivative is going to be y prime equals 1/2 x. Don't forget to subtract 1. But I'm going to write 1 as 2 over 2. Negative 1/2. Again,
some teachers will let you stop there. Others will make you persevere. So it's going to be 1 over 2, x to the 1/2. And some teachers will let you stop there, where other teachers will make you continue on. Dy dx equals 1 over 2 radical x. Now, notice the 2 is on the bottom, so that goes in the bucket. But you don't have to put that 2 there. If there's no 2 there, it's implied that there's a 2. And the 1 goes on top, and again, you don't have to put that 1 there. But that could be your final answer. And that's about as far as you can continue with that particular expression.
Now I want to find the derivative of these two. Again, there's really no numbers to manipulate, so you're probably going to have to at first go to your list of derivatives in the derivative table, and there it is, the derivative of e to the x. Wait a while. Is just e to the x. Salman Khan from Khan Academy goes into a big lecture on why that is. If you're curious as to why, he will be happy to show you why that's the way it is. But most students just want to get to the chase, and they like taking the derivative of e to the x. Now the derivative of ln, which is the natural log of e, again, I'm going to use my derivative table, is actually 1 over x. So that derivative is going to be y prime equals 1 over x. And they're pretty quick if you commit them to memory. And again, there's other videos out there on YouTube that will explain and actually derive why those are the derivatives of y equals e to the x and y equals ln x.